Okay, so I think as we did before, it might be a good idea to label these as just equation 1 and equation 2, just so we can reference them relatively easy, right? Now, most of the time when you have this many variables going on, the elimination method is a really good bet, okay? It's a really good idea. And what I want us to kind of think about here is, what exactly are we eliminating? What exactly is the goal of the elimination method? Usually its goal is to shrink it down so that we only have one variable or kind of one term variable that's still there. If we were to just add these as is, notice nothing would cancel out perfectly, right? We would still be left with, there'd be 2x squareds, there'd be 2xy's, there'd be 2y squareds. It's not necessarily a step towards anything that's helpful. So that's where we use the elimination methods approach of multiplying or dividing an entire row by a number. And a really good strategy here is to multiply this entire question or this entire equation by -1, which pretty much just changes its sign. So in the first one, x squared plus 3xy plus y squared is 22. The second one is now -x squared plus xy minus y squared is -6. Remember, every single term gets multiplied by a -1. So now when we add these two, we'll notice that the x squareds cancel and the y squareds cancel, and we've got 4xy is equal to, this would be 16. Now, from here, we have two options, and I would say that they're equivalent options. It doesn't matter which one you go with. We're going to divide by either the 4 and the x or the 4 and the y. In other words, we're going to write one variable in terms of the other. I'm going to just divide by the 4x. You could try this with 4y, and you'll be just fine if you do. So I've got my 4 and my x both cancel. I've got y is equal to, this reduces to 4 over x. Now, have we solved this? No, we have not. But what we've done is we've created a much more straightforward relationship between x and y that's not as muddy and just there's a lot going on over here. It's not like this, right? And that's kind of the point. We want it to be a little cleaner, a little smoother. The only thing I want to mention is, because we have a denominator, because x is in the denominator, we want to say find y, but x cannot be 0, because if it was, that throws this whole thing off, right? We cannot have a 0 in the denominator. So now what we're going to do is we're going to take this 4 over x, and we're actually going to go back to either number 1 or number 2, either one, and we're going to plug that 4 over x in everywhere that we see a y. My recommendation is going to be the second one. Nothing special about it other than I have fewer coefficients. Other than that, it doesn't matter, right? You could plug it into the first one. So we've still got an x squared minus x times, and this is where we're going to put 4 over x in its place, plus, and instead of y squared, we're going to put 4 over x squared equal to 6. Now there's some cleanup we'll do here, right? So you've still got x squared. The x's are going to cancel, so this is just minus 4 plus 4 squared is 16, x squared is x squared equal to 6. Okay? Now, what we're going to do next is we're going to clear fractions. And that means we're going to multiply every single term by this denominator value. So multiply by x squared. I know I'm allowed to do it because I already said it's not 0. I couldn't do this if x potentially was 0. But we already ruled that out. It's not going to be an issue. So you've got everyone times x squared. This gives us x to the 4th minus 4x squared plus 16, because these two cancel, equal to 6x squared. I'm going to move this over, and we've got x to the fourth minus 10x squared plus 16 is 0. Now, you might remember an equation like this from a little bit back, maybe a previous class, hopefully a previous class. And this, although it's not technically quadratic, is something we call quadratic in form. So bear with me. Again, this is kind of an older technique, but it's a super, super useful one. I can rewrite this so it looks quadratic, which means we can factor, use the quadratic formula, whatever method makes sense to you. I'm going to do that by taking this middle number, and I'm going to say let u tends to be our most common substitution variable, pick another one if you don't like the letter, is equal to x squared. That means, or that implies, u squared is that thing squared, which is x to the fourth. So if you see, we have both of those substitutions. U squared for x to the fourth, well, that's right here. And also, we'll go yellow, u for x, which is, for x squared, which is right there. So we make that substitution. Instead of x to the fourth, we write u squared minus 10, and instead of x squared, we write u. The 16 doesn't have an x, so it doesn't change, and it's equal to 0. So now what we do you see that this is something that factors a little cleaner, right? You can do this without substituting, but this is our most common approach. So now I factor this. We have a u, we have a u. I'm thinking the pair that works is 8 times 2. So an 8 there, a 2 there. 16 is positive, that means these have the same sign. 10 is negative, that means they're both negative. I get my negative 10 out of that, it works. This tells us u is equal to 8, or u is equal to 2. And I have to remember this substitution that we did. So I plug back in, x squared is equal to 8, or x squared is equal to 2. Now I want to solve this for x by taking the square root of both sides. So we'll square root, square root, square root, square root. We've got x is plus or minus square root 8, which we can clean up because this factors, right? X is equal to plus or minus 2 square root 2. Over here, there's not much that can be done, so you just get a plus or minus square root 2 as that answer. Okay? I know that was a lot of work, but this actually gives us 4 x values. All 4 are potentially solutions, and we need the y values. We have not done that yet. The good news is we have this equation from the very beginning of this question that says y is equal to 4 over x. So all we have to do is plug in our values. So for example, we have y, for example, we have x is equal to 4 over, we have, when x is equal to a 2 square root 2, y is equal to 4 over 2 root 2. This 4 and this 2 cancel, but we do have to rationalize. Times 2 times 2. We end up with y is 2 root 2 over 2. Again, cancel. You're just left with y is the square root of 2. So this ordered pair is 2 root 2 root 2. One answer. We do the same thing. So x is equal to negative 2 root 2. Plug it in. So y is equal to 4 over negative 2 root 2. 4 and negative 2 cancel to be negative 2. And then we rationalize. So we end up with y is equal to negative 2 root 2 over 2. Y is equal to negative root 2. And that's your ordered pair. Same thing, but with square root of 2. You've got x is equal to root 2. That gives us y is 4 over root 2. You rationalize it, so times root 2 times root 2, and you end up with y is 4 root 2 over 2, which definitely cancels, and you get y is 2 root 2. So that's your solution. X is root 2, y is 2 root 2, okay? And then its counterpart, x is negative root 2. So when you plug that in, you get y is 4 over negative root 2. You still have to rationalize like we just did. So times root 2 times root 2. So you get y is negative 4 root 2 over 2, which again, when you cancel, tells us y is equal to negative 2 root 2. So this gives us the ordered pair, negative root 2, negative root 2, and negative 2. And those are your 4 points. You're always welcome to plug them into the other question, no problem.